Our project is about predicting heroin overdose events in Cincinnati, Ohio. This video will display two sides. The first part will illustrate our app, and the second part will present our poison model. Overdose from heroin have skyrocketed nationwide in the recent years. From this picture, we can see the 2 years daily overdose count in Cincinnati. It shows there has a rising trend. In face of the tough situation, saving lives with naloxone, which can reverse the effects of heroin, is usually thankful. It's important for people who affect heroin to use it immediately. Our app is developed to allocate existing resources which can provide service of injecting this drug, training help for addressing the growing heroin overdose epidemic in Cincinnati, Ohio. The app displays a full overdose risk map for all of Cincinnati and shows users the level of risk in their area. Based on the overdose risk map, I add hospital, health department, and a healthcare center which can supply such service of injecting drug, professional training, and so on. After overlaying these layers, we can find that some labels lack of available health centers to supply such service. So we assumed that we can add fire station to supply the service because it is numeric and widely distributed, and the city of Providence has provided a safe station project. This is our app. Our app has two main functions. One of the functions is that it displays the overdose risk map by fishnet and the neighborhood. In the risk neighborhood map, we can click two labels to make a comparison. You can see the information of population, some overdose count, and area of each labels. The second function of our app will help policymakers to allocate the existing resources. When we click the health center, we can see all the location of hospital, health department, and the healthcare center. So then when we click the fire station, the location of fire station will present on the risk map. If you want to look for a specific label, you can click one label to see the information of health centers and fire station. For example, in this label, you can see that in the high-risk region, there has not only health center, so it is necessary for people to allocate service. And also, you can make a comparison with other label. Now, let's turn to the model part. Our dependent variable is reported heroin overdose incidents. From the heat map of the overdose report, we can see that the distributions of the overdose reports are highly clustered in the central area. So we divide the study area into two categories. The first areas with clustered overdose reports, and the second areas with less overdose reports. For the clustered area, we build the model 1. For the areas with less overdose reports, we build the model 2. For each category of the study area, we train a model use data in 2015 and 2016, and we use the data in 2017 as testing dataset for accuracy purpose. The dependent variables mainly contain three components: the demographic characters, environmental factors, and spatial components. Poisson regression is the primary method adopted in this project. In order to better capture the frequencies of the overdose reports, distributed fishnet was generated within the study area. Till now, we have built the two Poisson regression models for the clustered and non-clustered study area. In the clustered area, from the result, the predictor share the similar pattern with the observed overdose count in both non-clustered area. Furthermore, the distance to assault is the primary variable in the clustered area, whereas the distance to drug is the primary variable in the non-clustered area. Based on their fishnet locations, the two models are combined for the whole study area. This is a map of predicted overdose events based on neighborhood. Our MAE is 0.48, which means that by each unit, our model predicts less than one incident incorrectly. incorrectly. The final comparison with risk prediction and the kernel density hotspot show that the risk model outperformed the original kernel density model at a high risk level.